Last video we used the next hop self command to give reachability to an internal iBGP peer route outside of its autonomous system. Another way of achieving this is if we advertised the interface in OSPF and also advertise some of the direct links. And we're going to move on to the next one, which is the local preference, the next BGP attribute. And this is the topology that we're going to be using. So we're using the same topology actually, but now R4 has moved into AS123, and now R4 has moved into AS4, and it has a direct connection to R1. So we have R1, R2, and R4 in AS4, and then R3 is on its lonesome in AS456. And I have these routers actually open.
If you're enjoying the content, please consider subscribing, as 86% of viewers aren't currently subscribed.
Let's just see if I've done the connections. I don't think so. So that's AS3. It's going to be a bit confusing. And a lot of the students ask me with these, particularly with these kind of videos, how do we get good at BGP? This is how I'm demonstrating it. We could have just had a flat topology and moved straight on from next hop and continue with the BGP commands. But the more you configure something, the better you get at troubleshooting it and at configuring it. So we've wiped out the BGP config that we had previously, and we started again with just the IP addressing. So let me open up R1. Let's just do a show and see what we've got. We've still got some of the previous commands on there. Let me just wipe those off then. And let's have a look at what we're taking out. So all of these commands are coming off of the actual box. Let's commit that. Do a show now. And we see we've got interface GE00 going down to R2, but we don't have any connection to R4. What we do now. I'm not sure if there's actually any configuration on R4. Let's check. No. All right. So R1 is currently just got its IP addressing. We might as well continue with the rest of the configuration and then move on to R4 afterwards. So first let's set up the autonomous system. We're also going to set up the router ID. Oh, I'm on R1, so it will be 1.1.1.1. Now we can move it into the, because it's iBGP, I'm going to need an IGP. I will use OSPF. Let's do that now. That will give us reachability to all of our interfaces using OSPF. Let's do the BGP configuration. And it will use the local address as the neighbor address. So we've got a connection to 2.2.2.2 and also 4.4.4.4. We set the local address as 1.1.1.1. I think that's it for R1. Let's commit that. We're going to put a comment, say local preference. R1 is completed. Now let's move on to R2. Still a bit of residue config there, so let's just clean that up. Oh no, sorry. So we've got a connection to R1, which is what I'm looking for, and also a connection to R3. Okay, that's good. And we've done the OSPF, so let's do our BGP configuration. Set the neighbor as, which neighbor? 1.1.1.1. I think we only need that neighbor. Okay. And let's set our local address as 2.2.2.2. Is there anything else we need? Not as far as I know. Let's do that. Comment as error in neighbor 10.1.12.1. All right. Oh, the ASs have changed. So let's have a look. Top, edit routing options. Show. Autonomous system is 4. Oh, so did I set it the top edit protocols BGP for the group RC internal? Let me do a show under this. Yeah, I set the peer AS as 1, 2, 3. The peer AS should be 4. So set the peer AS as 4. Show. Yeah, let's commit that. Great. Now onto R4. We need a connection to R1, which will be 10.1.14.4. That's 24. Then we need to advertise it into OSPF. And then BGP. And what I probably should have been doing, and we will test it though, but what I should have probably been doing for reachability, I need to advertise the directly connected routes on all of these routers with policy into BGP. But let's see if it works without it. But if it doesn't work, then we know that's the reason. No, top. I don't even want that. Let me just say top. So run ping 1.1.1.1. Can I ping it? Yes, I can. Can I ping it? Yes, you can. So go on then. Go on. Let's see if it's come up. Can I ping it? Yes, you can. Can I ping it? Yes, you can. Okay. So the BGP peer has come up to 1.1.1.1, which is excellent. Exactly what I want to see. Now the last one to do is R3's configuration. Okay, that's good. Now this is going to be an eBGP peer, so we only need to run eBGP, and we also don't need to run any kind of interior gateway protocol, so no OSPF. I thought maybe I could do both of them, but they didn't allow me. So autonomous system number first, and now the router ID. Now I will do some policy. So edit policy options, policy statement, R3 routes, set term 1 from route filter 3.3.3.3 /32 exact. RC external is going to be our group name. Our type is going to be external. Our peer AS is going to be 4. We're going to have 2 neighbors. So the first neighbor is going to be directly connected of 10.1.34.3, and the next neighbor is going to be 23.2. And then let's export our policy. Our 3 routes. Let's commit that. Let's see if any neighborships have come up. So we'll check here. Run show BGP summary. Active at the moment. Let's wait a few seconds for BGP to converge. Okay, it's come up on R2. Active on R3. And that's probably because I've missed out some, active going towards R4. And that might be because I haven't done the correct configuration on R4. 1 ping 10.1.34.4. That's probably what it is actually. So let's do a show command here. Our neighbor should be 10.1.34.4 because our local address is 10.1.34.3. And there we go. Now it's up. So what I'm going to do, let's see if we can discover that route that R3 advertising to BGP on R1. And we can. It's 3.3.3.3. And we see that the path to get here is going through R2. Let's see if we can actually ping it without advertising or without advertising our directly connected route into BGP. No. But it's not, reachability is not actually the issue here. I could do another policy and advertise it for reachability, but all we want to be seeing, because we see a star in BGP, we want to see the path change from 10.1.12.2 and it should go to this one, 10.1.14.4. And what will actually happen is that this path may actually disappear as this one becomes more preferred or the only one using. And we're going to basically change our exit path. So let's have a look at our topology again. And in this topology, we can see that the path is following from R1, going down to R2, and then across to R3. By changing the local preference, you affect how the local device or how the devices exit the local autonomous system. So instead of going out of R2's exit interface, it will exit from R4's interface by using local preference. And to do this, we will jump onto R4 under BGP for the group of edit group RC internal. We should be able to just say set local preference and highest win. So the default is 100. So if I was to make it like 250 and say commit, we jump back over to R1, up, so R2 did actually stay in the routing table, but we can now see that the local preference has changed to 250. The star means that that's the route that BGP will use, and our next hop is now 10.1.14.4, meaning that our exit to get to the 3.3.3.3 network has changed from being R2 over to being R4. And that's it for local preference. Let's move on to the next one.